In this video, we are going to look at solving some trig equations that involve tangents or cotangents, secants or cosecants. So here's an example. So find all solutions to. So the first one, root 3 cotangent of theta plus 1 equals 0. And I'm going to add in here my unit circle so we can use it as a reference. So the first thing that we're going to do is we're going to solve for the cotangent. So subtract 1 from both sides. So root 3 cotangent theta equals minus 1. Divide both sides by square root of 3. So cotangent of theta equals minus 1 over root 3, which means that the tangent of theta would have to be equal to minus root 3, because remember the cotangent is the tangent flipped over. So in this case, now what we need to do is we need to figure out what values have a tangent of minus root 3. So remember, tangent is the y value over the x value. So if we were looking for places where if I take the y value and I divide it by the x value, I get minus root 3, that would be here. Right? If I were to do the division out here, I'd have root 3 over 2 divided by minus 1/2, which would be root 3 over 2 times negative 2 over 1. So the 2's would cancel. We just have minus root 3. The other place that this is going to happen is down here at 5 pi over 3. So the two places are 2 pi over 3 and 5 pi over 3. Remember, that's just the places on the unit circle. This did not give me any kind of qualification that I had to stay on the unit circle. So I could be here at 2 pi over 3, or I could rotate around a whole entire time first, this unit circle, and then stop. I could go around a lot of times and then stop. So remember, these are the ones where we need to state that, how we have all these infinite solutions. So remember, we're going to write down first off the two places, so on the unit circle. So theta equals 2 pi over 3, or theta equals 5 pi over 3. And then I can, once I'm at one of those angles, I can rotate around the unit circle one whole time. So we're going to add that 2k pi, where k is an integer. And that is what is accounting for the fact that we can go all the way around this circle that many times. So we'll try another one here. What about... So b, the cosecant of theta plus 2 equals 0. So subtract 2 from both sides. So the cosecant of theta equals minus 2. Remember, cosecant is the sign flipped over. So this is saying that the sine of theta would have to be minus 1/2. And we're just, remember, sine is the y value. So that's going to happen when theta is equal to 7 pi over 6, and again when theta is equal to 11 pi over 6. And then again I could go around that circle, so we have to add that plus 2k pi. So anytime you're trying to solve for values in an interval, or not in an interval, where they don't tell you, oh, between these, between 0 and 2 pi, you are going to have to add on this plus 2k pi.